Now I have thought of something that I can continue with both GameObject Find and getComponent. And this is usually where it breaks. How can I show how it breaks? And when people see errors, especially the main error, null reference exception, where does all that come in? Right, so we still have our example scene. I'm just going to remove all the script components of everything. Okay, so we're back to a capture collider and a mesh renderer on the player, and on the NPC we have a capture collider, a renderer, and a rigid body. Let's just remove that script as well. I'm just going to save the scene. This is going to be my base scene. Now let's start all again from scratch. So let's create a new script. This will be my GameObject Find example 2. Yes, I'm terrible with names. So what can we do here? Let's open up that new script and let's create a variable in which to store our component, or to store our game object, to store whatever we want to store in our variable. Our variable is going to be my target. Again, excellent naming convention. And let's just keep it simple, keep it of type GameObject to start with. So again, in the start function, my target equals GameObject dot find. Now let's see if we can make this break immediately. Let's try and find a game object that is named something that we don't have in our scene. Okay, we don't have terrain, I suppose. This could be any kind of name. Okay, so we're asking it to find a game object of terrain. And let that compile out. I'm going to put this on the NPC, example 2. So it's looking for a game object called terrain, and we don't have anything that is named terrain in our scene. So let's just hit play and see what happens. Okay, nothing scary so far, but normally where we populated this variable, it didn't find any game object called terrain. So it says none. See, if we click on it, nothing's flashing up. Okay, so where does this break for people? Okay, just say we thought that we had found it. So my target, let's just say transform position. Alright, so we're going to access the transform component of the game object. And let's set its position. Or we think we are setting its position. Equals a new vector3. And let's just set it to 5, 5, 5. Okay, so if I'm writing this script, I'm thinking, yeah, I'm finding my terrain, and my game object that is named terrain, and I'm going to set its position to be there. Now let's see what happens. So we typed it all incorrectly, there's no compilation errors. Now what happens when we hit play? There we have it. Okay, the null reference exception. What does that mean? Let's break it down. Null reference. So we've asked to assign our variable here. We're looking for a game object. It says none. So there's nothing in here. When there's nothing in here, it's not a 0, it's a null. It doesn't exist, it's empty space. So that's what null means. So a null reference, we're trying to refer to a null. And that's indeed what we're doing. Here's our reference. Oh, sorry, here's our, okay. So here's our reference here. We're trying to access the transform. We're trying to access the transform of a null. Now a null doesn't exist, so it doesn't have a transform. So that's exactly what the error means. And it's exception because it's exceptionally bad. I don't know. Okay, so null reference exception means we've tried to do something, and we've tried to do that to something that does not exist. And that's exactly what this means. So again, if you double click on the error message, let MonoDevelop open it up and highlight the offending line. So it's saying, Unity's trying to tell us, no, this doesn't work. This reference here to this variable is a null. It doesn't exist. Okay? So just say you were trying to do this, and you were trying to do it anyway. This is where we can start to check things. This is how we can make it so it doesn't break on us. It could break further down the line, but I'll show you how it can even be smart and tell us that something's going wrong without just throwing an error. So, as I said, we're storing a reference in a variable, but if we don't have it, it is called null. So if my target is equal to, beg your pardon, we're checking if something exists. Okay, so we have a variable. We want to check if that is assigned, if something exists. So we want to check if it's not equal to null. So we're going to say, okay, if we found our target, that means it's not a null. So if we have a target, let's set its transform position. And just for us, and so I can prove a point, we can say else, and we'll send ourselves a debug. Now I've normally used Debug Log. You see the IntelliSense is working now. We've got a couple of options here. We've got a log warning, and we've got a log error. Let's just show the difference. And we can say here, my target is a null. So that will give us a warning. And I was going to show off the other debug. Debug log error. No. Now let's make it better. Help me. Okay. So let's see what those different type of debugs look like in the console. So let's just recap. We're trying to find a game object that is named terrain. We're going to check, did we find it? It's not equal to null. So if we found it, let's set its position. Else, we didn't find it. So I'm going to send ourselves a couple of messages. Oops, let's stop, let things compile. Clear that because that was from the last run through. There's no compilation errors. Let's hit play. Okay, we don't have a null reference exception anymore because we took care of that. We checked if we had a null. Now we do have a null, so we've fallen into the else. So here's our debug log warning. So this is what the debug looks like. My target is a null. And then there's our error. So it's just doing exactly the same thing. It's just giving it a debug, but we can even modify the symbols. So we can tell ourselves, well, this is not so great. This is really bad. Just by using different types of debug. And again, we can double click on these to see where they came from. Now we have it. There is our warning with the yellow exclamation. And we have our error with the red exclamation. Okay. So I think that's looking pretty good.